Microphone check 1 2 1 2. You are now tuned in to the network,
Bruh.
the YouTube channel that takes complex networking topics and dumbs it down in more simple language. Let me see if I can get this camera going here. Nope, there I am right there. Shout out to my man Gee B Scoo in the building. Said not much, bro. Just getting in the mood with these drums. Yeah, that was a instrumental I used to use back in the day when I used to my short-lived rap career and everything like that. Now I use it as an intro for my networking channel. So shout out to Gee, man. Appreciate you for tuning in, man. Y'all make sure y'all check out my man Gee at what is it? kbtrainings.net. I can't remember if it's kbtrainings.net or kbtrainings.com. But he pretty much teaches the same stuff that I do. Pretty much computer networking, routing and switching, and that sort of stuff, man. Firewalls, all that, man. Although his is better, his stuff is better quality over there than me over here. But we are going to do an ERGRP lab. That is the network topology right there. We got looks like we got Florida routers here. This looks really familiar to a lab we did a long time ago. I can't remember which one, but this is EIGRP authentication. So we've got, let's see, let me bring out the map. I thought I bought a map here. Yeah. So we've got, y'all know I'm in Orlando, so there's Orlando right there. We've got Daytona. Basically, we got Florida over here. And I believe we're going to set EIGRP between that router and that router. Set EIGRP between those two. And then I believe we're going to set up authentication, right? So that's one way for us to create an EIGRP, I guess, neighbor relationship without mitigating the risk of being without an attacker. So when we put in our authentication key on there, we mitigate that risk and everything like that, right? So cool, thanks, bro. Yep, that's what's up, man. We're gonna give it a couple minutes for some people to tune in. Y'all know I like to wait to like tune in at start the lab probably like at the 10-minute mark and stuff like that. So in the beginning, I kind of talk shit for a little bit.
A few moments later.
Kind of go on with what we got going on and things like that. That's what it is. kbtrainings.com. I couldn't remember. I knew it was KB Trainings, but y'all visit him at that website right there. Like I said, he teaches the same stuff that I do. It's just much better quality than this over here, man. So, but y'all know how I do over here. We keep it simple and we just get straight to the point and stuff like that. Y'all also want to visit. Make sure you hit that like button and the subscribe button. Also visit Boson.com. They are running a sale on this application that I use on my channel right here, right? Y'all know this is a network simulator. They are running a sale, a Black Friday sale. You put in the code CYBER22, CYBER 22, and they give you 30% off of this application right here, right? So y'all could do these labs along with me and stuff like that. That way y'all can help me out whenever I mess up, or let me see, bring this window up. And we kind of do it together and things like that, right? Make sure also you join the Discord server. There's a link at the top of the chat right there, right? And see, where is it? Yeah, there's a link at the top of the chat. From there, I will let you know when I stream or if I cancel a stream or anything like that. I kind of snuck up on y'all today. I guess I forgot to do that. Put in the Discord chat that I was gonna stream today. Maybe I could do that right now just to let some people know. Let me go ahead and do that. Where is it? Where is the share button here? I'm gonna have to open up another window here, I guess. Hold on, y'all. Give me a second here.
A few moments later.
Hold on. I gotta go to the your channel live, and I believe it's this button right here. I'm gonna have to pause that so I don't have any dual share. Share. There it is right there. Copy. I'm gonna put that in the chat for anybody. That's gonna be in the Discord server, by the way. That was not it right there. There it is. Streaming now, guys. Tune in. Yeah, I guess I kind of snuck up on them. Normally, I'll give you a heads up when I'm gonna stream. I typically stream between 6 p.m. and 8 p.m. Eastern Standard Time. lately it'll be it was Monday through Thursday because on the weekends I don't have my daughter or anything like that. So it's a lot easier for me to do it during the week and everything. So what else we got going on? We gonna stream in a couple. I mean, we're gonna start the lab in a couple minutes here. Um, this one was pretty interesting right here. Vice Society ransomware claims attack on Cincinnati State College.
No, God!
I guess we got another school that was hit by ransomware. That's something new, right? How many schools we got hit by? Schools, the hospitals, those are like the prime targets for these ransomware attacks, man.
FBI, open up!
The Vice Society ransomware operation has claimed responsibility for a cyber attack on Cincinnati State Technical and Community College. I guess it's a small school, with threat actors now leaking data allegedly stolen during the attack. The hackers posted a long list of documents on their Tor data leak site they claim was stolen from the college, indicating that a ransom was never paid. The documents here's the thing about these looks like we got a new subscriber. I didn't see where it was at. Saira N has subscribed. Appreciate you for tuning in and appreciate you for hitting that subscribe button. But it says here, oh yeah, so y'all know these ransomware attacks, man. It's like damned if you do. You could pay the ransom, right? And then they still leak your data or just not unlock your unencrypt your files or anything like that. Or you don't pay the data and they still, leak your data and not unencrypt it. So it's like damned if you do, damned if you don't. If you don't, if personally, I don't think I would pay for it if my stuff was I'm gonna just have to take the L and change passwords and do all of that because it's like ransomware. They don't really have to give you the data back. Like who's ever heard like honest criminals? Really? There's no honor amongst thieves, right? So they may or may not be honest and just give you your data back or unencrypt your files. 9 times out of 10, I don't know what we got. Professor Black Ops in the building. Appreciate you for tuning in, and also appreciate Naira for hitting that subscribe button. But Professor Black Ops, what's the likelihood of somebody unencrypting your files or not releasing your data after you pay the ransom? Like, do we have any statistics on them not releasing that data if you pay the ransom? Because I'm thinking like they'll just be like sucker, after they get your ransom. But the hackers posted. Oh yeah, we already said that. The documents date from several years ago. Jesus Christ. Until November 24th, 2022. So I guess they released that. They've got data from a long time ago until yesterday, possibly indicating that the threat actors maintain access to the breach systems, but this has not been verified. Yeah, they could fake that data and say, hey, look, we've got all this information, but they got to verify all of that stuff too. All documents on the Vice Society site have been made freely accessible to visitors and contain PII, personally identifiable information, in the leaked files. Restoring operations, and this is exactly what I'm talking about. Cincinnati State College informed its 10,000 students, that's a small ass school, and 1,000 staff members that they suffered a cybersecurity incident earlier in the month, warning that online services and restoration to regular operations will take time. I know them network engineers and security engineers are sweating their ass off right now, man. The latest update on a cyber attack came on Tuesday this week, announcing the restoration of on-campus networks and email, partial internet access, and classroom computers. However, voicemail, network printing, VPN access, network and internet share drives are all unavailable, while a range of online application and registration portals are also offline. Damn, that really sucks, man. Man, I worked at a school system. It was a bit bigger than this school right here. This is a technical, like a smaller community college. And thank God we never got hit, or at least that I know of. Yeah, I would have known about it. But I could just imagine when a school gets hit, man, what that does to a school, man. Like we had what was that school? It was a school called Lincoln State. It was a historically, an HBCU basically, historically black college, university, or college or university. And they were hit with ransomware attack, a cybersecurity attack. They had to shut down operations after 156 years. It was a historical school, man. And they had, these schools can cripple these cyber attacks can cripple the financial system online, as you can see, online registration and things like that, and just pretty much shut down the school financially, man. So the college has posted FAQs for the employees, current and new students, guiding them on how to interact with the administration until systems return to normal operations. However, there aren't workarounds for all services, so the disruption from the cyber attack remains significant for the college.
FBI, open up!
And then they go on and on about the long history of targeting, like I said, targeting educational institutions ranging from K-12 school districts and universities. Hospitals really get hit hard with ransomware. And then they had a couple related articles there. Cybersecurity, Professor Black Ops with the STIGs of the day coming through. It says Cisco router must be configured to authenticate all routing protocol messages using NIST validated FIPS 198-1 message authentication code algorithm. This is known as the traffic attraction attack. So that is one of the rules that we would have to abide by if we are trying to be STIGs compliant. Again, we're going to be doing what am I saying?
You stupid.
We're going to be setting up EIGRP authentication, I believe, between Miami and Key West. These two routers right here at the bottom. We are consoled into each one of these guys right here. I wanted to read one more to y'all too. We got Navy Bliss in the building. Navy Bliss said, I need help knowing what the market wants for entry-level networking jobs. That's simple, man. Just go to Indeed and do entry-level networking or network engineer or something like that. Junior network engineer. And then you'll see, and then put your if you want to just kind of get a general idea, just put the job title and you'll see descriptions. You don't have to put the city area or anything yet. If you want to know what's local to you, then you could do that. Put, network engineer, Chicago, Illinois, or something like that. And it's real simple, man. But if you want a really general idea of what they want, just don't put the city, right? And then you'll know, like, in whatever country you're at or whatever city you're at, and you'll get a good idea of what they're asking for. And it really depends on what you're trying to do. I already have CCNA related stuff on my resume, but what else should I put on there? VMware, Python, what did you use? Thanks. I put down what I know. Simple as that. If you put something you don't know, they're gonna ask you questions about it, and you're gonna be stuck like a deer in the headlights, right? So just put down what you are an SME in, or subject matter expert in. If you are really good at EIGRP, put down EIGRP. I know about I've implemented it at this school or at this job right here. I know a lot about it. Even if you haven't really implemented it in the real world, if you have real good knowledge about it, they're gonna look at that as, oh, this is free game for me to ask questions on. So whatever you know, you put that down. Simple as that. Professor Blackout said, I know I'm making it real simple. I'm making it sound easier than it really is, but it's as simple as you don't overcomplicate it. Professor Blackout said most big time hackers organizations will not release the data because no one would pay them after the first company got burned. So their word is money. Yeah, very, very true, man. But I see what you're saying. Hold on, y'all give me a second, man. Y'all give me a second. Somebody at the door. Hold on. All right, my bad, y'all. All right, so had some company and stuff. So, where were we at? Okay. Yeah, he said most big time. Yeah, they won't. So basically, Professor Black Ops is saying they really got to pay that ransom back, because then they can come back in and do the same thing. Because then the word will get around. Oh yeah, this hacking organization, they ain't gonna give you your data back if you pay them. So don't even pay them. So if they know that a company is going to release back the data, then they're like, okay, if you pay the ransom, you'll actually get the data back. So they really, like he's saying, their word is their bond. They really got to be, that's, I guess, one thing they got to be honest about. So thanks for the advice. Yeah, no problem, Navy Bliss. I know I made it simple as simple as can be, but it really is. Don't overcomplicate it. Just whatever you're looking for, you should just look for that. If you have a certain security, or if you want to know what jobs are hiring for the A+ certification, or what jobs are hiring for the CISSP certification, guess what? You go to Indeed.com or Career Builder and type in CISSP and see what jobs come up. You see what I'm saying? So yeah, no problem for that. One more thing I wanted to look at before we start the lab too. I don't know if y'all know about this right here. Speedguide.net. Tesla's full self-driving beta is now available to everyone in the U.S. Tells you a little late for that one. After gradually expanding access to its so-called full self-driving FSD beta for the last few years, Tesla is opening it up to everyone or anyone who has paid for it, Elon Musk announced in a tweet. Y'all know I've been really looking hard at some Teslas recently, and I was asking because my cousin has a Tesla also, and I was asking him, hey, what do you think about the FSD feature? Is it overrated or whatever? And I knew that it was a beta program. They just released it to only certain people to join the beta program. Basically, they tested the autonomous system for the Tesla cars, right? Basically, automatic driving, and only certain people could be a part of that program. You had to have like a certain safety score is what they call it. And now they're actually releasing it to everybody in the public. So if you got a Tesla and you paid for that program, whatever, everybody can join it or whatever. There are a couple of caveats though. FSD is only available in Teslas which have the required hardware, and only for drivers who have bought the FSD option, which currently costs 15 grand. Bruh. If you buy it separately. It used to be, when it first came out, I believe like with 8,000, then it went to 10,000, then 12,000, and then recently they moved it up to like 15,000, I believe in August or October, maybe, I can't remember. If all those requirements are satisfied, drivers can then request the feature from the car's screen. Full self-driving is a set of features that ideally brings Tesla cars very close to autonomous driving, with the driver entering a destination into the navigation system and the car driving there on its own, though the driver has to be ready to take over at times. I don't know if y'all have seen, if you ever go to YouTube, just type in FSD Tesla and you'll see the actual car driving itself, stopping at the red light, changing lanes and all of that. Yes, it actually drives itself. But, you know, you got to be ready because the car will do some dumb shit and you could get into an accident or quite possibly lose your life. The FSD beta began rolling out in 2020 to a limited number of customers by October this year. That small group had ballooned to 160,000 customers, according to The Verge. The beta required drivers to have a certain safety score in Tesla's built-in safety score feature, and they needed to have driven at least 100 miles with autopilot. Yeah, so, yeah, I've been looking at those cars too, and just today they released this information. Now it's available to everybody in the public. So that is pretty dope. Professor Boxoff said, Navy Bliss, keep grinding. The first one is the hardest to get in the job world. Yes, exactly. Very true. Each one gets easier after that until you get 50 plus. Yeah, you get old like this guy over here, man. Professor Blackops, when he was when he got into the field, this is what he was doing to get on the internet. You know, I like messing with you, Professor Blackops, man. But anyway, yeah, that's true. The first job is usually harder. Let me go ahead and stop that. The first job is usually hard. It took me, I'd say, a good. When I decided I wanted to get into networking, I want to say it was about 2015, 2016. And I got my first job as a NOC operator, NOC technician in like 2017. And then I became an analyst after that. And then I became a network engineer. So yeah, it's usually that first one. Just keep applying. And at the same time, keep studying. So let's go ahead and get started with the lab. I know I've been doing a lot of talking here. Again, we're doing EIGRP authentication. Say that 5 times in a row. We're going to set up authentication, I believe, between those two routers right there, Miami and Key West. Let's bring up the map. There it is right there. First thing they want us to do, let me bring up the steps. I'm going to put up on the side over there so that way it's not in this window. Understand EIGRP authentication process and configure the routers in the simulated network to require EIGRP authentication before they advertise routes or to accept routing table updates from EIGRP neighbors. Then they go on with the address table. They give us some basic commands here. The routers have been configured with admin as the password and console at the console prompts, Cisco as the password at enable, and San Fran at the VTY lines. I know Professor Black Ops don't like those easy passwords, but oh well, they set it up that way. Verify routing on Key West. Display the routing table. Where's Key West? Key West is down here at the bottom, just like it is in real life, right? Let me make that a little bit thicker. Bloop, bloop. There is the Key West router. They want us to go in there and see what his routing table looks like, right? How does he get to these networks? Key West is over here at the bottom. Bloop. They said the password was admin. No, ADMIN. And let's do a show IP route. Take a look at the routing table. We have a pretty lengthy routing table there. I'm not going to go. Let's see what it wants to do. Compare these routes to the networks shown on the network topology diagram. All routes to all networks present. Let's see. Let's just pick 2 networks and then go from there, because I'm not going to go through this entire routing table here. Where's the map at? Let's say, for example, this right here. This looks like the 100.4 network. Do we have a route there? We go to the network topology. Where's that window at? Geez, I got so many windows open here. There. So we go to Key West. And we said 100.4 network. That's it right there. So we do have a route to get there. He either goes this way or he either goes that way. We'd have to do a trace route to find that out. But they ain't ask us all that. They just said all the routes to all networks present. Let's see if we have a route to the, let's see what else. I guess the 1.0 network. Let's see. No, the 4.0 network. Do we have a route to get there? 4.0 network. 192.168.100. 4.0 network, which is right here. Yes, we do have a route to it. And it's through EIGRP. So, yes, we're pretty good there. I'm not going to check every route. How many possible paths can be taken by traffic between host A and host B? Host E and host B, rather. So look at the map right here real quick. Host E is located. Come on, man. Host E is right here. Here at the bottom. Let me make this a little bit bigger. Boom. Boom. He said, that's facts. Yeah, man. I had to shoot at you. My first modem, 19.2 baud modem. Me yelling, "Mom, don't pick up the phone. I work it." Man, tell me about it. If anybody is old enough like me and Professor Black Ops, y'all know if y'all had to be on the internet, nobody could use the phone when you're on the internet, right? And then you get a little dial tone right there, and then that's when you can get on the internet. He said 1992. Yeah, my earliest memory of getting on the internet was at the library in Kissimmee and opening up an email account. And that was 1996, either 96 or 97. I can't remember. I believe 97. So, yeah, Professor Blacks go way back with that. So how many possible paths between host E and host B? We got host E down here at the bottom. Hold on. Host E is at the bottom. Host B is right here. We have a way to get there. We can go 1 or 2 ways. Y'all see that? That's how many paths can be taken. What path does host E follow as it moves to the network to host B? So they saying, which way does he take? From there to there, right? So host B's IP address is 1.2, 192.168.1.2. So we got to do a trace route from there, right? Let's go to the PC, host B, right? Host B? No, host E. We got to go to host E. So he's there at the bottom, host E. And we do a trace route. Trace RT to 192.168. What is it? 1.2. Y'all see what I'm doing, right? We do a trace route that shows us each hop that it takes to get there. The first hop is 5.1, which is located where? Wait, host E, right? We're on host E right now, right? Yeah, we're trying to ping host B. First hop was 182.5.1. 5.1 is right here. So that's his first hop, right? He go from here. The next hop probably .17, which is here. And then the next hop is 100.9, which is here. So he go this way. That makes sense? Right? That was that question. Anybody on the question so far? Y'all with me so far? Again, he went from, they wanted to know, how does this PC go to that PC? Does he go this way or does he go that way? And basically we went and did a trace route, what's called a trace route, that says which way he goes by each hop, and each hop is the router each router you pass, right? He went from this hop to this hop to this hop, which lets us know that he went this way to get there. Right? That make any sense? Y'all make sure y'all hit that like button and that subscribe button if this is the first time you tuned into this channel. The next question was, why do the routers in this network choose the path as you noted in the previous step? Probably because, well, these are equal costs. This is 512. That's 512. So, I'm not even sure. They're probably the same cost. They're both serial links. So, who knows why it took that way? Let's see. It ain't have nothing to do with the, it could be because that link came up first. Who knows? But one thing I like about Boson NetSim is they give you the answers right at the bottom. So they said the reason why is because EIG routing protocol chooses the Key West to Miami to Tampa. So basically he goes from Key West to Miami to Tampa. I don't know why you would go to Tampa, but from Key West, it's a lot more, I guess it's prettier in Key West, although there's another set of crowds there. Anyway, to Orlando path, because all the links in this path are 512 kilobits per second, just like I mentioned. The Daytona to Orlando link is 64 kilobits per second. Oh, so that's why. Y'all see, this is the reason why I took that way. I didn't even look that far. So this is an equal path. That's 512K. That's 512K. This is also 512K. But notice we got this right here. This is a 64 kilobit link. So this is a slower link. If he go this way, it's slower. So he chose to go this way. You know, he chose the route that is faster to get there, basically. Task 2. We are going to, actually, we got one more question in task 1. And we've got how many tasks? Looks like we've got 4. First part is verifying routing. What is the EIGRP autonomous system in the simulated network? What purpose does this number serve? So basically, remember we said routers that are grouped together, they're grouped together in autonomous systems. They're neighbors with routers that are in the same autonomous system as them or have interfaces in the same autonomous system. What autonomous system it is, we are going to go into that router. Let's pick what was the one at the bottom? Key West, right? Let's pick Key West. Best way to do that is just do show. Well, we got to put the password first. Admin, because Professor Blackops like that password there. Come on, man. ADMIN. Bad secrets. Show IP protocols, and that lets us know what we're running. We are in AS number 100. That lets us know, right? Another way we can do it is how? We could just do password was Cisco here. We could just do show run and then section router. That lets us know. No, my bad. I forgot to put section. Does the section keyword work here? Yes, it does. Router. That's what I love about Boson NetSim. They are getting better and better with this application simulator. Again, go to boson.com, put in the keyword cyber22, and you get 30% off of their application. And yes, I am a sponsor of them. This lets us know what we're running here as well. Another command that we could do to find out is show IP EIGRP interfaces, I believe. We could do AS100. There's a whole bunch more we could do too. But verify connectivity. Let's just do host A to host B. I mean host E to host B. So we're just gonna have this PC ping that PC. We already did the trace route, but let's just do that because they wanted us to ping it, right? Let's go to host E, and he was what, 2.1? Ping 192.168.2.1. Uh-oh. Oh yeah, we dropped the packet and it finally went through. No, we didn't drop the packet. We got 5 out of 5, so we're good to go there, right?
All I do is win, no matter what.
Understand unauthenticated EIGRP. Full connectivity is established when you load this lab. EIGRP is properly configured and routes are being advertised between neighbors. Briefly explain the requirements for routers that are using EIGRP to exchange routing table updates, right? So we have 2 routers. Before they become EIGRP neighbors, they say hello to each other, just like we do in a real neighborhood, right? They actually send packets that are called hello packets. He says, hello. The other one says, hello. And then they say, I speak EIGRP. And then the other one says, I speak EIGRP. Here's my router ID. Here's my router ID. And then they exchange routes. He was like, oh, you speak EIGRP too? Great. Here's some routes that I know of. And then the other one says, here's some routes that I know of. And they exchange routes. But before they just say hello to each other, we also have to have the same K values, So he's like, hey, you know, what's his name? It's just like, I don't know. We try to find commonalities amongst each other, just like we do with real relationships, right? We make sure they have the same K values. We need to have the same primary subnet. We also need to have the same, the interface have to be in the same primary subnet, and we also have the same AS number. So those are the things that have to be required before we exchange routing table updates. What security risks related to EIGRP exist when a network is configured in this manner? So if you're saying hello to a supposed EIGRP neighbor and he doesn't have, like, say, like, let's say he's just he fakes like he knows EIGRP. He's a fake EIGRP router, right? And we just accept him as a neighbor. He could give us fictitious routing updates. And like Professor Black Ops said, in order for our organization to be STIGS compliant, well, guess what? We need to have EIG authentication. So not only does he have to speak EIGRP, but we got to make sure we have the same EIGRP key. So that's another requirement. So he says, oh, you have the same, what's the same K value? What's the K values you got? And there's 5 K values, K1 through 5. And he says, what's your primary subnet? We have the same primary subnet. And he says, what's your EIGRP key? If he doesn't have the same key as me, then guess what? We're not neighbors. We can't be neighbors because I'm not going to accept your routing table updates because you're going to tell me, you're going to give me fake ways to get to the 7-Eleven or whatever, right? Whatever the case may be. Briefly explain how implementing EIGRP authentication might mitigate the security risks that you previously described. So same thing. As long as, if I ask you, hey, what's your EIGRP key? And you give me some key that's not the same key as mine, and I'm just like, okay, I'm not going to listen to this guy because he don't have the right key. So he's going to give me some fictitious routing updates, or he's just going to try to hack into my network. No, I'm good. What are some potential disadvantages of EIGRP authentication? How might they be mitigated? Some potential disadvantages are if we have to, there's more overhead. When we set a EIGRP key, then us together, we have to have the same key. We got to set keys for a whole bunch of routers. Unless you know some kind of like script or Python script that can, send these keys, it's a lot of work to set up these keys and stuff like that. So that's a disadvantage right there. Task 3, implement EIGRP authentication. So now we're going to get to the nitty gritty and actually do this stuff, right?
346 minutes later.
I know I had to do a little bit of whatchamacallit, lecturing here first, right? Configure authentication credentials on Key West. So we're gonna go to Key West. We're gonna create a keychain named MyKeychain1 and add a key with the key string San Jose. Create this key as key number 1. Okay. So we go to global config mode. We say key chain. They said name it MyKeychain1. And add a key with the key string San Jose. Create this key as 1. Create this key as key 1. So next thing we do is key 1 like that. And now we do the key string San Jose, all lowercase. San Jose. We'll probably drop our, no, my bad. It's, you put the keyword key string like that. And then you do a key string, which is San Jose. That will probably drop. No, that doesn't drop it yet. We have to actually put in authentication on the interface. Then it drops the neighbor relationship there. Prepare to set up EIGRP authentication between Key West and Miami. No, actually, we got to do. I'll go to Miami and do the same thing. Except it's MyKeychain1. So we'll go to Miami. They said, press enter. My bad. Password is admin, just like that. Enable. Cisco. Show. Actually, we didn't do the chain yet, so we go to global config mode. Key chain. He said my key chain 2. And then the key ID they said was 1. Key string was San Jose. And that was pretty much it for those two. We've configured the credentials. Prepare to set up EIGRP authentication between Key West and Miami. Y'all make sure y'all hit that like button and that subscribe button if this is the first time you tune into this channel. Y'all know I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Lately, it's been sometime between 6 and 9. That's what I've been doing. I'm trying to lab every day. Which interfaces on these routers are responsible for sending routing table updates between Key West and Miami? So we look at the map real quick. We set up keychains between We set up a keychain on Key West and also Miami, right? They asked us which interface on these routers are responsible for sending routing table updates between Key West and Miami. Well, we've got this interface right here and this interface right here, which is what? FA01, and the other one is also FA01. So we got to set up, that's where we are going to, so once we do the keychain with the string and the ID, then you go to the interfaces and that's where you apply it. That's where the actual authentication happens, right? Configure the authentication mode on the interfaces you noted in the previous step. So on FA01 on both interfaces, both routers, right? So we go to, let's do the first one, Key West at the bottom. We go to that interface FA, was it 01? Yes. I'll show y'all real quick, right there. FA01, that interface right there. Right? Y'all with me so far? Anybody got any questions or anything? There's a lot of smart people in the chat room if I can't get to it, because y'all know I'm trying to stream and lab and look at the chat at the same time and read these steps and everything like that. We set up the mode by doing IP authentication and then, authentication mode. I believe you do EIGRP 100 and then you type in MD5. There's two types of authentication, I believe, right? Or is it just one? Yeah, it's one type. MD5, that turns on the mode. They said to do that on both sides. Press mode, that's going to drop the relationship. Notice we've got this syslog message here that says EIGRP is down on that interface. Authentication mode changed. Well, guess what? Let's go to Key West to do the same thing. Exit, go to that interface, which was FA0 / I'm sorry. Was it 01 or 10? I can't remember. Y'all know I got a short-term memory.
You are so dumb. You are really dumb. For real.
Right there. 01 and 01. So we're setting up authentication between these two interfaces, right? That interface and that interface right there. Right? Y'all with me so far? So 01. We say IP authentication mode, EIGRP 100, MD5. Let me type in that 5 just so I know it's there. But notice that didn't bring it back up yet. It's not going to bring it back up until you put in the string, right? Configure the authentication mode. Oh, we did that already. Then he said configure the authentication key that will be used for EIGRP authentication. Reference the keychain you created earlier. So now we can actually put in that keychain on the actual interfaces. So this is how I remember authentication. You got the keychain, right? Then you have the actual key, and then off of the key you have a little string, right? You take all of this stuff that's on the key, the keychain and stuff like that, and you put it on the interface. That sets up authentication. But there's two commands that you got to put on the interface for it to actually be applied: the mode and the actual keychain. So we just did the mode. Now we do the chain, which is IP authentication, and I believe it's what you just type in EIGRP. No, I can't remember. Question mark. We'll see. Y'all know I ain't afraid of question mark. Keychain. The actual keychain was you do EIGRP 100. The name of the chain was, what was the name of the chain? I believe it was just my chain 1. There it is right there. My keychain 1 rather. Yeah, so my key chain 1. Press enter. And let me show y'all the whole command so y'all can see. We got to do the same thing on the other side. But look, I did it wrong. See that? That's why I'm glad I scooted over real quick. We got to fix that H. It's actually a lowercase h. There's no space there. Let me make sure that's correct. That's it right there. Do the same thing on the Miami router. Was it Miami? Yes, Miami router. Go to that interface, which was FA01. You know what? Yeah. So IP authentication keychain. The keychain was EIGRP 100. And then the name of the chain was my, if you scroll up, we'll see it was my chain 2. It's like this right there. Was it my keychain 2? My chain 2. My keychain 2 rather. What was the other one? Yeah, my keychain 1 and my keychain 2. This one is my keychain 2, right? My keychain 2, yeah. Press enter. Don't think it'll bring it back up just yet. There it is right there. We got a new adjacency. So that brought back the neighbor relationship we had there. Do keychain names need to be identical on each router? do key strings need to be identical? As you can see, we had different keychains, but we had the same string. So the keychain don't need to match, but the key string need to match. What type of hash are key strings used to create? Well, I just explained. Well, I don't think I explained it, but it's MD5 is the type of hashing algorithm that we use for the authentication, right? What else they want to know? Do keychains need to be authentic? Oh, we did that. Is Miami sending EIGRP updates from or receiving updates on its LAN interface? So we go to Miami. Let's take a look at the map real quick. They said on its LAN interface, which is this side. So this is our WAN interface. This right here is our LAN interface. They want to know, are we receiving updates on this right here, FA00? How do we do that? We can find out by just doing show IP EIGRP interfaces, and we'll see. I'll be sending and receiving. The LAN interface, I believe, is FA00. Right there. We have 0 peers, so it doesn't look like we have, well, that doesn't necessarily mean we don't have any, we're sending or receiving, but it does mean that we don't have a neighbor on that side. That's all it means. We don't have, obviously, we just have a PC there. We have a neighbor over here, but we have a PC on that side. Are we sending and receiving updates? One way we can tell is just doing, I believe, just debug, EIGRP, or debug, EIGRP packets, and then can we just do on that interface? No, we don't want to do that. We could just do, what's a good way to do that? You could just do show IP protocols like this, and you'll see if we had a passive interface, I believe it would let us know right in here. It will let us know if we have a passive interface. And remember what a passive interface that says. It means you're sending and receiving hellos. You're not sending or receiving hellos on that interface. So being that it's not in here, I believe we're sending some, but we're not receiving any. But what did they say? I want to see what they say. Miami is the only router connected to its LAN. Therefore, it's not currently sending updates from or receiving updates on FA00 interfaces. So no, they didn't tell us to run any specific command. Is Key West sending updates or receiving them on its interface? So they want to know. We look at the Key West router. Oh, well, we did Key West. They want to know if Miami. They want to know if Miami is sending or receiving some on this side. So let's go to Miami. Where's Miami at? Oh, we did that. We did Miami already. Now they want us to do Key West. We do a show, same thing here, show IP protocols. There is no passive interface, so there you go. That's the answer to that question. Why might it be a good idea to configure EIGRP authentication on those interfaces that we just mentioned? Why might it be a good idea to configure EIGRP authentication on the fast Ethernet interfaces of Key West and Miami? So they want to know right here where I got these circles at, right? Show you. Why should we set up EIGRP authentication on this right here and this right here? Well, just like they said, what if this guy was a hacker and this guy was a hacker? You know, or we have some sort of unauthenticated device get onto our network. We set up authentication on that side. They can't send us fictitious updates or basically perform a man-in-the-middle attack or anything like that. But what is the official answer, though? It would be a good practice to configure EIGRP authentication on the Key West's FA00 interface and Miami's FA00 interface to protect the routing topology in the event that an unknown or unauthorized router is connected to the Miami LAN or Key West LAN. So just like I said, but just in another way. Y'all got any questions or anything so far? Y'all let me know. Make sure y'all hit that like button and that subscribe button. And again, Boson is doing a Black Friday sale, 30% off of this application, right? You just type in the code CYBER22, CYBER22, and you can get 30% off this application. Last task right here, I believe. Configure, verify EIGRP authentication. Display the routing table. Compare the contents of the routing table with the routes you previously observed. Do you see any changes? Well, We brought down EIGRP, then we brought it back up. So there is no change, but I'll show y'all the routing table anyway. Let's just do a show IP routes. Same routing table, right? We have route to the 4 network, the 3 network, the 2 network, the 1 network. We have these other EIGRP networks, so nothing really changed. We just pretty much bounced that ass. The EIGRP routing update, at least. From host E, ping host A. So from host E, where's he? So host E is down here. They want us to ping host A. And they're probably going to ask, which way is he going? Is he going this way to get there? Or is he going this way to get there? He's probably going to be going the one at the bottom because this is 512 kilobits per second, whereas this is 64 kilobits per second, right? Do you see any changes? No, that's not what they were asking. Are these pings successful? So let's go ahead and just ping it real quick. 2.2. Let's go to host E and ping 2.2. Ping. Oh, there it is right there. 2.2.
That was easy.
We got a reply. Are these pings successful? Yes, they are. If not, review the configuration. So we don't need to do that. And then from host B, ping Key West's FA00 interface. So let me look in the back real quick. They want us to do from host B, this guy right here at the top left. They want him to ping Key West's, Key West is down here at the bottom right, to ping the FA00 interface. So the local area network right over there, 5.1. So go to host B and ping 5.1. Host B is located right over here and ping 192.168.
Come on now,
I
dog.
got 2 dots right over there.
Come on, man.
My bad. He said 5.1, right? Yeah, 5.1.
That was easy.
Got a reply. So that was good. If not, review your correct. If not, review and correct your configuration, which we've done. Remove the keychain on Key West. Now they want us to remove all our work there, man. All that work we did, man.
Come on now, dog. Come on, man.
So we're gonna go to global config mode. We're just gonna say, was that keychain config? It was this right here. Actually, we just do no keychain. What is it? We'll just do a show keychain. They just wanted to remove keychain 1. So global config mode. No keychain, my keychain 1. So we remove that. That's probably going to tear down that neighbor relationship. Wait for it.
We have sort of a problem here. Yeah.
Let's see. Maybe not yet. Maybe it'll do it in just a second. In the meantime, there it is right there. I was about to say, delete all routes from Key West's routing table. So we go to Key West. We do that with what? Clear IP routes. And then you do a star. That deletes all the routes. Right? That's how you delete all the routes. Let's do a show IP routes. And we see we got no routes over there. I didn't mean to do that right there. That's for Professor Black Ops over there.
We have sort of a problem here. Yeah.
After the network has converged, display Key West routing table. What have you observed? Well, they're all gone now. Not even the damn local routes. That's crazy. There it is right there. We had to refresh it, and there they go right there.
You are so dumb. You are really dumb. For real.
How are the changes that you observed in the routing table related to the removal of the keychain? Briefly explain. Well, basically, we lost all of our EIGRP routes. Remember? This is how the routing table looked like before. We had all of these Ds right here. Throw some Ds on it. Which indicates that is a EIGRP route. But then once we removed the keychain with the no keychain, where is it? With the no keychain right here, we removed it. We lost the EIGRP adjacency. And then after that, we cleared the routing table with clear IP route star. And then we lost all of our routes. And then now we've only got connected and local routes. So in other words, Key West, he only know about this network over here and this network over here. connected in local routes, right? And that's what happened there. How are the changes? Yeah, well, I just explained to y'all about that. On Key West, recreate the keychain that you previously deleted. Jesus Christ, man. You're killing me over here, man.
Come on now, dog.
Let's go back to Key West.
Come on, man.
They making us. They just want us to. They just want to demonstrate what happens when you take the keychain and remove it and do all of that, right? So keychain. Now we got to do key 1. Key string is what was the key string? I believe it was. I'm glad I showed it. Key string was, there it is right there, San Jose, just like that. So key string, go back over there. Keychain 1, key ID is 1. The key string is San Jose. That should bring up that relationship. There it is.
Boom.
Bam. Adjacency.
Bop. Bada bop. Boom. Pow.
Next thing they want us to do was on Key West, recreate the keychain. We did that. After the network has converged, display the routing table. What do you observe? So remember when we deleted the keychain with the no keychain right here, we deleted the keychain. We lost the neighbor relationship. We cleared the IP routes. We had an empty ass routing table. We refreshed, and now we only see connected and local routes. We recreated the keychain. Now they want us to see, and then we recreated the keychain. We got the neighbor adjacency again. We do a show IP route. And now we got those routes back. Throw some D's on it. Which indicates that it's an EIGRP route. Next thing they want us to do is based on the behavior you observed in the previous steps, what conclusion can you draw regarding the operation of EIGRP authentication between Key West and Miami? Well, we have to have the authentication key in order to see EIGRP routes. Finally, complete the network configuration. For more experience with EIGRP authentication, configure EIGRP authentication on the Tampa and Orlando serial links. So we go to the map, we'll see Tampa located over here, Orlando located over here. So basically they want us to do the same thing. We're going to set up authentication between that interface and this interface. So 000 between Orlando and Tampa. In case y'all don't know, I'm in Orlando, so we'll start with Orlando, which is over, where's he at? He's over here. You just gotta double check. Password is admin. Enable. We say Cisco. And we do a show. Actually, we'll just create that keychain. This configuration is not graded as a part of this lab. So we can create these. We can create these keychains, but it's not going to grade us. So let me go ahead and grade it first. See if we've done everything right so far, and then create those keychains because I think they're gonna mark us wrong. But if we put those down. So we do a grade, and you'll see right there.
All I do is win, no matter what.
Recreated the lab successfully. I typically stream again Monday through Thursday, 8 p.m. Eastern Standard Time. But y'all can stick around y'all can stick around if y'all want. We'll just go ahead and just finish those EIGRP authentication keys right there. So we'll just do Orlando. Let's go resume lab. So we're pretty much done here. They just want us to wash, rinse, repeat, get some practice in, right? I'm going to call it my keychain 1 on both sides. And we'll give it the key string of, let's call it Black Ops, if he's still in there, right? Nah, who's in here? We'll call it Navy Bliss. We'll call it Navy Bliss, the key string, right? So we're going to say key chain and call it Navy Bliss. Right, and we're going to give it key ID of 1. We're going to say key string is, I guess we can call it the same thing too, right? But we're just going to say Orlando. Orlando. Right? We got to do so we created the key chain, the key ID, and then the key string. And now you got to go to your interface and do those two commands. In this case, we got to do it on which interfaces? 000. And 000 on that side, right? Interface 0/0. We say IP authentication mode, EIGRP 100 MD5, and then you notice it took down a neighbor relationship, right?
We have sort of a problem here.
And we type type in IP authentication Y'all know where that sound clip is from? uh, it's one of my favorite movies, man. What we say? IP authentication key chain, and the keychain was called Navy Bliss. No, we got to type in EIGRP 100, and then the string, the name of the keychain, which in this case was Navy Bliss, right? Yeah, Navy Bliss, like that. Press enter. And then we got to do the same thing on the other side, which was Tampa, right? Make sure. Yeah, this is the Tampa router, right? So we did this side already. Now we got to do that side already. And once we did that one side, once we did this side, it tore down the neighbor relationship, right? Because he has the authentication key, but he don't. So that's why I took down that relationship, right? We got to go to the other side and do the same thing. Password is admin. Enable is Cisco. Go to global config mode. We say key chain. We'll call this key chain Black Ops. Black Ops, right? Key ID is 1. Remember, because the chain don't need to match. It's the key string that need to match. Key 1. We say key string. We're going to call the string. The string was, that has to match. That was Orlando. Press enter. So we got the key and the key chain. Now we go to the interfaces with those two commands. Interface serial 0/0. IP authentication mode, EIGRP 100, MD5, and then we say IP authentication, authentication, EIGRP, no, my bad, keychain, EIGRP 100, and the name of the string was, I mean, not the name of the string, but the name of the keychain was, we just named it, Black Ops, all lowercase, Black Ops, press enter. That should bring up the neighbor relationship. And we got the adjacency. So we basically put the key and the key string right on this side. Then we applied it to that interface. Then we did the same thing, and then that tore down the neighbor relationship. Then we did a keychain on this over here, and then we applied it to the interface, and that brought back the EIGRP neighbor relationship between those two guys again. So again, make sure y'all join the Discord server. There's a link at the top of the chat right there. I'm gonna try to stream tomorrow as well. What are we gonna do? I believe we're gonna do another EIGRP lab, but it's not gonna be authentication. I'm just gonna pick one and we'll find out. For now, comment, like, subscribe to the network.
Bruh.